All right, let's continue on our review. We'll look at slope-intercept form for an equation, talk about characteristics of an equation of a line. So here, number 8, you see a linear equation. You've got two first-degree variables, x and y. And with that said, right now it's in standard form, where we have our variable terms on one side and our constant term on the other side. With that said, what we would like to do is write in slope-intercept form. So we're talking about lines, right? Slope-intercept form, right? We'll define our key characteristics of a line. It'll tell us about the slope, and it'll tell us the y-intercept point. So let's go ahead and write up here in our notes. What is slope-intercept form? So let's review that. Slope-intercept form we know is y equal mx plus b. All right, so if you solve a linear equation, right, like this one with two variables x and y, if you solve it for y, you're going to get slope-intercept form where the slope is the coefficient of your x term. So again, m references the slope. And the slope tells us everything about a line. It tells us our rise and our run between the 2 points. It tells us our direction. It tells us whether it's increasing, decreasing, or horizontal, just by knowing that value of m. And then b tells us the y-intercept point. So our y-intercept, which is the ordered pair, or the point at which our line would cross through the y-axis, would be at the location of 0b. So remember, with y-intercept, you're talking about an ordered pair. Of course, on the y-axis, the x-coordinate's always 0. But the y-intercept location is at the value of b. So let's go ahead and identify the slope y-intercept for this equation in number 8. So our first step, right, is to solve it for y. What does y equal? So that's our question. So as we do that, we need to go ahead and move the x term over. So let's use the addition property of equality. Let's go ahead and add a 3x to both sides of the equation. As we do that, we have 9y. We've got 9y equal to 3x plus 18. And then we'll divide out our coefficient of 9, right, on both sides so we can get y equal. So we're using the multiplication property of equality. We're multiplying both sides by 1/9 or dividing by 9. And as we do that, we get the form that we're looking for. We get slope-intercept form. So that implies y is equal to, and let's go ahead and reduce 3/9. We know 3 divides into 3 one time. 3 divides into 3, or 9, 3 times, so it reduces to 1/3. So our coefficient of x is 1/3. And our value of b, as you can see, is 18 divided by 9, or 2. So here's slope-intercept form, right? So here's y equal to mx plus b form. So we have our value of m and b. So that implies our value of m, which again is the slope. The slope is equal to 1/3. And our y-intercept point is the ordered pair of 0, 2. So there's m, and there's our y-intercept. So we found our slope and y-intercept for the given line, which means this is an increasing line. It has a positive slope. It's a line that crosses through the y-axis 0, 2. So if you were to graph it, the graph of this line would take this shape and have a y-intercept at 0, 2. So again, that'd be a way to check it if you were to graph it in your calculator, right? You could look at those characteristics. All right, so looking at that, that's our equation there, number 8. Now, number 9, as you look at this linear equation, you notice you have no x term, y equal a constant. So here's a horizontal line equation. So a horizontal line equation, right, is an equation of the form y equal some number b, right? No x term, right? Y equal b, again, what's x, right? There is no x term. So we have the coefficient of x being 0. So this implies m is 0, no slope in a horizontal line. All right, so there's our value of m. So again, y-intercept, well, our y-intercept would be the ordered pair, right? 0, -15. Y equal b. So yeah, if you were graphing this line, here's what the graph of this line will look like, right? Pass through the y-axis at 0, -15. If we wanted to sketch its graph. So slope is 0, right? All right, no x term. So again, I want to make that note back up here. No x term, right, in a horizontal line equation. Slope is 0. All right, now that's equation of line y equal -15, which we graphed there beside it. Now, as you look at this last equation, we have x equal to a constant. So with x equal to a constant, we're dealing with a vertical line equation. So we talked about a horizontal line equation. Now we've got a vertical line equation. All right, x equal to a constant, x equal to some number a. So with that said, with a vertical line equation, that implies slope is undefined. All right, we do not define slope on vertical lines. And the reason for that is slope is rise over run. There's no run factor in a line that's going up and down. It's not going right and left, so you're dividing by 0. If you look at the change in the x-coordinates, think about your definition of slope. So again, as we're answering the slope, m is undefined when we're dealing with a vertical line equation. So again, x equal to a constant. Y-intercept, there is no y-intercept. So we have no point at which this graph would cross through the y-axis. Right? So if you were graphing this line, it would have this graph here, and it would have an x-intercept point of 13, 0. But there's the graph of x equal to 13. So you can see our graphs, right, of these lines. All right, horizontal, vertical, slanted, our 3 types of lines that we look at together. If you wanted to graph them all on the same plane, you could. If you're looking at a graph of these 3, so that might be something good to do together now that we have found all 3 together. If you were graphing these 3, let's go ahead and build our x and y axis. So for example, if you want to graph x equal to 13, we would go to 13 on the x-axis, right? We would plot that point. And we graph in that vertical line, x equal 13. And then if we want to graph y equal -15, we can graph it in blue if you want. We go down to -15 on the y-axis. We can plot that point. Here's the horizontal line, right? Here's the line y equal -15 with a y-intercept at 0, -15, which means it's perpendicular to the vertical line. And you want to graph in y equal 1/3 x plus 2, you could, right? You graph that in, you have a y-intercept right here at 0, 2. Right, and you have a slope of 1/3. You go up 1, right 3. You can plot another point on here, which would be the point 3, 3. Up 1, right 3 would be 3, 3. But there's a graph of that line. Right, you see it in here. So there it is. There's our graph of line y equal to 1/3 x plus 2. All right, so that's equation of lines. So as you see their characteristics. Now I want to go a little bit further into that definition of slope that I just used in graphing that slanted line and finding that point of 3, 3. So remember I talked about going up 1 and right 3, right? A rise and run. So as we talk about finding the slope of a line, you need 2 points. So let's go ahead and write down our definition again. So m, which reference slope in math, is again your rise over your run. It's a ratio of rise or run. You change in y, your vertical distance between the 2 points, divided by your horizontal distance. You're changing the x-coordinate. So y2 minus y1 over x2 minus x1. So as you're looking at this line here, it's slope here 5.2, and let's go ahead and just to make it a little easier, instead of plugging in the formulas, let's go ahead and plot these 2 points and graph this line. So right 5 up 2. Here's that point 5.2. Right 7 and down 5 units. Down here in quad 4, here's 7, negative 5. So as we graph this line passing through these 2 points, there's a sketch of that line. Let's find the slope. All right, what does m equal? What is your rise over your run? So as we do that, let's go ahead and look at it here in blue. So we're at 5.2. Let's look at where we're on the y-axis. So we're at 2 on the y-axis. And we travel down to the next point on this line that we plotted, which is 7, negative 5. Means we're going down to negative 5 on the y-axis. Right, here's your rise factor. Here's your vertical distance. So here's the change in y, right? Here's y2 minus y1. So we've gone down, right, 7 units. Right, that's a difference. That's your rise factor. Right, now what's your run factor? Your run factor is how far right and left you move. So where did we end up on the x-axis? So we've gone from 5 over here to 7. We've gone right 2 units, right? The change in the x-coordinates. So again, if you were looking at that, there's x2 minus x1. We can write that here beneath it. There's the difference in the x-coordinates. There's 7 minus 5, which is 2. And again, this is y2 minus y1. If you subtract the y-coordinates, right, what is 2 minus negative 5? Right? 2 minus negative 5 is 7. That's 2 plus 5. So you see the rise and run. So that's equal to 7, right? And that's a negative 7, right, as we're looking at the rise on those. So we subtract the y-coordinates, right? That's 7, again, down 7, right? And then right 2, right? So we got negative 7 over 2. So we look at that vertical distance. So again, you can subtract these coordinates, right, to find that slope. So m is negative 7/2. We went down 7 units. And again, if we were looking at the y-coordinates, just to show that, I'll just erase this real quick. All right. We'll build back in our y-axis, x and y-axis. Again, here's our axis here. We'll put these points back on here. And down to negative 5. But again, as we're subtracting the y-coordinates on this one, right, as we went down 7 units, that was a negative 7. Right, but again, y2 minus y1 shows that. So subtracting the y-coordinates, that's negative 5 minus 2, which is negative 7. So again, that's your rise factor. And we see the x-coordinates, their difference. So yeah, m is negative 7/2. Down 7, right 2, right? That's the distance traveled from 5.2 to 7, negative 5. So your vertical distance, your rise factor, your horizontal distance, again, is your run factor, how far right and left you moved. And you can always plug it in the formula from the get-go, but I like to see it. I'm not big on just plugging numbers in the formula. You can look at it easily and tell your slope, right? Once you've graphed your line, once you've labeled some points, you just need 2, right, to do that. So again, if at the beginning we labeled these, point 1 and point 2, right, we could have plugged it right into that formula. So negative 5 minus 2 over 7 minus 5, which is negative 7 over 2. But yeah, there's our slope of that line. All right, which again tells us it's a decreasing line, right? Negative slope's going down from left to right. Positive slope, it's increasing, it's going up. There's no slope, 0 is horizontal. If it's undefined, it's vertical. So remember, our characteristics of slope tell us everything about the line. All right, let's move on to problem number 12. Let's write a slope-intercept equation for a line with the given characteristics. So we're going to find the equation of the line passing through the points -7, 0 and 6, -2. So again, if you wanted to plot the 2 points, graph the line, look at, we could. Let's go over here and just sketch it just to show what we're looking at. Give a little more detail to our graph. But -7, 0, they're giving us the x-intercept point, right? And 6, -2, right? 6 down 2 over here in quad 4. Right, you can graph in this line. So there's a sketch, right? This line passing through those 2 points. Now, what we don't know, right? We don't have the y-intercept. So there's the y-intercept point. There's 0b, right? We want to find that. That's our point we're looking for. We need to find the y-intercept. And then the slope, we would have everything we need to graph the line. Or I sort of say, write the equation line. Now, your first step, our first step is always to identify the slope. So step 1 is find the slope. Right? So again, we're trying to create a slope-intercept form equation. Well, let's get the slope first. So in the end, we want an equation of the form y = mx plus b. Now again, slope is your rise and run between any 2 points. So to find the slope, right, find m, rise over run, we can use these 2 points. So again, we can find the rise and run. We can look back at our graph. We can find the vertical distance and the horizontal distance. Right? We're going what? Down 2 units, and we're going right 13 units. There's your rise and your run, right? Rise, run. But again, it is the change in the y-coordinates, y2 minus y1 over x2 minus x1. So the difference in the y-coordinates, -2 minus 0. And the difference in the x-coordinates, we've got 6 minus -7, which simplifies to -2 over 13. So yeah, m, there's m. So we've got half of what we need. There's our slope. So as we're writing out our equation, again, y = mx plus b, that implies y = -2 13ths x plus b. And that's our next step. So step 2, we got to find b. We don't know the y-intercept point. We weren't given that point. We'd have everything we need. But we got to find b. And to find b, I'm going to plug in one of the points they gave us. Plug in a point. All right? Plug in a point and solve for b. I'll write that down here in notes. Plug in a point on the line. And solve for b. So we'll go ahead and do that. So I'm going to use the ordered pair. Let's use -7, 0. So we know it passes through -7, 0. So there's our x and our y coordinate. So that implies y, 0, = m, -2 13ths times x, -7, plus b. So I picked -7, 0. I could have picked 6, -2 at 2 choices. Doesn't matter. Either one, you plug in and solve for b. So 0 = to, now -2 13ths times -7, that's 14 13ths plus b. And then as we solve that for b, we got to isolate. So we got to subtract 14 13ths over to the other side of the equation. And we'll have what b equals. So here's our y-intercept location. So b is equal to -14 13ths. So now we have b. And that implies our slope-intercept form equation, y = -2 13ths x plus -14 13ths, which is y = to -2 13ths x minus 14 13ths. But there it is. There's our slope-intercept form equation given this line. So there's the graph of the line, right? And here's its equation. So again, finding the slope and finding the value of b. So again, get your slope first. That's your first step. Once you have your slope, you start writing out your equation, y = mx plus b form. So you know the x term, and then you just plug in a point to find b. There's also point-slope form that we talked about during our unit. We talked about having a point, any point, and the slope, and create the equation, y minus y coordinate equals slope times x minus x coordinate. That works too, and you got to solve for y to get in slope-intercept form. To me, the easiest thing, just use slope-intercept form. Right, y equals mx plus b, we can use that to create any equation of a line. So let's go ahead and look at our next set of problems. So 13 through 15, review parallel perpendicular properties. So determine whether the given lines are parallel, perpendicular, or neither. All right, so as we're looking at parallel, and let's write in here our definition. Our parallel lines have the same slope. All right, parallel lines, the slopes are equal. All right. Now, perpendicular lines, let's write down its characteristic. All right, so remember, parallel lines mean two lines that, of course, never intersect. So they have to go the same direction. That's why they have to have the same slope, right? The same slopes are not going to touch. And we got to assume their y-intercepts are different because they're the same. They'll be on top of each other. They'll be the same line. Now, perpendicular lines, the two lines intersect at a 90-degree angle. Well, with that, the slopes, they have to be opposite reciprocals. So with perpendicular lines, M1 and M2 will always make a product of -1. All right, so these are opposite reciprocals. All right, so again, to be perpendicular, for two lines intersecting a 90-degree angle, the slopes are going to have to be opposite reciprocals in order to make that product -1 happen. So if we're going to determine whether these pair of lines are parallel or perpendicular, or neither, maybe they're just intersecting but not at a 90-degree angle, it comes down to comparing the slopes. So that's what we want to do. So our work, right, find the slopes and compare. All right, so let's go ahead and do that. So we'll go ahead and take equation 1. So as we look at equation 1, so again, we have 3x minus 2y equal 5. Well, let's solve for y. We'll go get slope-intercept form. So we'll go ahead and move that 3x over. So we can subtract the 3x on both sides. Right, we'll work on getting it slope-intercept form. So -2y equal -3x plus 5. And we divide out our coefficient, -2 on both sides. And we get what we're looking for. We get y equal to -3 over -2, which is positive 3/2 x, plus 5 over -2, which is minus 5/2. So line 1, I'll call this y1. We know slope of line 1 is 3/2. So m1 equal 3/2. All right, let's take line 2. I'll do it in blue. Now our second equation, we had 2x plus 3y equal to 5. As we solve it for y, let's go get it in y equal form. Again, moving the x term over, we'll go ahead and subtract 2x on both sides. So 3y is equal to -2x plus 5. And we'll divide out our 3 on both sides. And we'll have slope-intercept form, -2/3 x plus 5/3. So line 2, we'll call this y2. Slope of line 2, m2, is equal to -2/3. Now, as we compare these two lines, right here are two slopes. So again, m1 is not equal to m2, so that implies they're not parallel. They're definitely going to intersect. These lines are going different directions. One's increasing, the other's decreasing. But what we do have is opposite reciprocals. What's m1 times m2? What's 3/2 times -2/3? That's -6/6, or -1. So that implies perpendicular. So we have two lines that intersect at a 90-degree angle. So these are perpendicular lines. m1 times m2 equal -1. So yeah, the product of our slopes is -1. All right, so there's example perpendicular. let's go to problem 14. Let's do the same thing. Let's find the slopes. So we take our first equation. Let's go ahead and get y equal 4. So I have 2y equal to negative 6x plus 8. As I divide out the 2 on both sides, I've got y equal to negative 3x plus 4. Right? And then our second equation, well, let's go ahead and write down slope. So there's line 1. So M1. So slope of line 1 is negative 3. All right? And as we go to line 2, we'll do it here in blue. Let's go get y equal. So that one I have 4y equal to negative 12x plus 17. As we divide out the 4 on both sides, I get what? Y equal to negative 3x plus 17 fourths. So divide the 4 out. So with line 2, y2, there's our slope. Coefficient of x, negative 3. M2 is negative 3. So as we compare these slopes, M1 equal M2, that implies parallel. So we have two lines that would never intersect. So we have perpendicular in problem 13, parallel in 14. And let's check out the last one. Here in 15, let's go ahead and get our slope-intercept form. So negative 2y equal negative 3x plus 20. Divide out our negative 2 on both sides. And I get y equal to 3/2 x minus 10. So line 1, M1, I have a slope of 3/2. As we go to line 2, and do the same thing. Here we've got 4x plus 3y equal 20. Well, let's go solve it for y. What's y equal? Well, I got 3y equal to negative 4x plus 20. Divide out my 3 on both sides to get it y equal form. So y is equal to what? Negative 4/3 x plus 20/3. So line 2, M2, equal to negative 4/3. So line 1, we found its slope, which was positive 3/2. Line 2, we found its slope to be negative 4/3. So as we look at comparing these two, right, what do we have? We have different slopes. M1 is equal to M2. They would be parallel, but they're different. So these are not parallel lines. We also see that the product of these two slopes, they're not opposite reciprocals, because their product does not give us negative 1, right? Our product gives us here negative 12 over 6, or negative 2. All right, so it's negative 2, which means it's not equal to negative 1. It's not perpendicular either. So these are neither. So neither parallel. So these are just intersecting lines, but they don't intersect at a 90-degree angle. All right, so again, M1 times M2, the product was not negative 1. A conclusion on that one as far as not being perpendicular. So you see an example of each type. So comparing lines, again, everything comes back to slope. Slope tells us everything we need. We're talking about lines. All right, moving on. Let's go to problem number 16. Let's finish up parallel perpendicular properties. Do another example, a little more applied. This time we want to write out the equation of a line in slope-intercept form that passed through the point negative 6, negative 8, perpendicular to the given line of negative 5x plus 3y equals 6. And that's key. We need our new line to be perpendicular. So we want a slope-intercept form equation. So in the end, we want an equation of y equal mx plus b form. Now, our first step is to find the slope. So we have a point, right? We're going to have to find the slope of the new line. All right, so let's go ahead and do that. Let's find the slope. Let's find m. Well, first thing we'll do is find the slope of the given line. So let's go ahead and get y equal form. So we'll go ahead and take that and solve for y. So 3y is equal to, we've got to add 5x over to the other side of the equation. And then we'll divide out our 3 on both sides. Right, and we get what? We get y equal to 5/3 x plus 6/3, which is 2. So there it is in slope-intercept form, right, as we solved it down for y. So our given line, line 1, so the slope of line 1 is 5/3. So to be perpendicular, so my new line, all right, so remember, find the slope. Perpendicular line, right? Opposite reciprocals. M1 times M2 must be -1. So with M1, let's go ahead and write it right beneath here. My new line, my perpendicular line, if it was parallel, we would use the same slope, but we want it perpendicular. We need the opposite reciprocal. Opposites are -5/3. Reciprocals, we flip it, -3/5. Yeah, if you were to multiply those two together, right, 5/3 times -3/5, you get -15/15, which is -1, perpendicular. So our new line, its slope, so we got the line now, so that implies M2 is going to be -3/5. So for the perpendicular line. All right, so we found that slope, M2. So now we can start writing out our equation. So that implies, right, y equal -3/5 x plus some number b. Well, that's our next step. That's step 2. Let's go find b. And to find b, we plug in a point. So plug in your point. Plug in -6. Got to pass through. Remember, it passes through. We'll write that down. All right, passes through 6/8. So there's x, there's y. So that implies, if you're using your slope-intercept form, 8 equal -3/5 times x times 6 plus b. So plugging in that point as we simplify, I got 8 equal to, well, -3/5 times 6, that's -18/5 plus b. And let's go solve for b. So we'll go ahead and add the 18/5 over to the other side of the equation. All right, as we do that, again, we're getting b by itself. So b is equal to 8 plus 18/5. All right, as we've plugged in that point. All right, and be careful. So if somebody check me now, the passing through, I wrote down the wrong order pair. This was a -6, and this is a -8. And be careful here. So it ends up being what? A positive 18. So -6 times -3, that's a positive 18/5. So be careful plugging in the information. So -3, again, that's 18/5, right? And we got to subtract that over to the other side. All right, so let's go ahead and do that. So we're moving that over again. That's got to be moved over. So I'll do it in blue. So it's a -18/5. Move it over to the other side. All right, so there it is. So we got 8 minus, or -8 minus 18/5. So -8 minus 18/5. And we're subtracting fractions. Let's go ahead and get a common denominator. Need a denominator of 5. So let's go ahead and multiply numerator and denominator by 5. As we do that, we get -40 over 5 minus 18/5. As we subtract those, I got -58/5. Right, -40 minus 18, -58. So there's b. So we got m and we got b. So that implies our perpendicular line equation, y equal to -3/5 x minus 58/5. There's the new line equation. All right, passing through -6, -8, perpendicular to the given line. Right? So again, finding the slope, that's always a key piece of information. Since we were talking about perpendicular, we knew the slope would have to be opposite reciprocal. Need a product of -1. We're talking about perpendicular lines. Two lines intersect at a 90-degree angle only if their slopes have a product of -1. So once we found that slope, we were ready to go with slope-intercept form, plug in the information, find a point. We had the point -6, -8 that it passes through, so we plugged that in, and we solved it for B. As we did that, we have our y-intercept location. But there it is. There's our new line. So there's the perpendicular line equation in slope-intercept form. So we'll stop there. We'll take a break and continue on with our review.